Okay, the two new formulas that we have now. One is called the midpoint. Oh, you're going to use this a lot next year in geometry. And it is, if you're given two endpoints, how do I find the point that's right in the middle of the segment? So if this is point x1, y1, and this is x2, y2, what would this one have to be? Well, it's just like finding an average of two items. So if I said you got 100 and you got a 70, well, you go 100 plus 70 is 170 divided by 2, you got an 85 average. So the midpoint would be add the x's, divide by 2, add the y's, divide by 2. That is the midpoint formula. You need to memorize that formula. So if I say you have 2 points, let's say 4, 2, 6, 8, and I said, what would the point be that's right in the middle of those 2 points on a segment? Those 2 points are the endpoints. What would the midpoint be? Well, you just go 6 plus 4 is over 2, and 8 plus 2 over 2. So it'd be 10 over 2, 10 over 2, so it'd be 5, 5. Really, I don't think this is that bad, I hope. So, try one for me right now. Find the midpoint of this problem. Find the midpoint and then turn me back on. Okay, so you would go 12 plus 6 over 2, 3 plus 1 over 2. So that'd be 18 over 2 is 9. 3 plus 1 is 4 over 2 is 2. And if you think about it, 2 is 1 unit from 3, but it's also 1 unit from 1. 9 is 3 below, and this is 3 above. So that makes sense. So did those formulas pretty quick. The last one, the distance formula, I think I'm going to develop it because you see it on the ACT sometimes. If you have a point and a point, you want to find out how far apart they are. I'll call this x1, y1, call this x2, y2. We're going to use a method that's used in proving things several times. We're going to take and drop a point so it's directly below this and directly to the right of this. So we have a right angle right here. Oops. So that would be our right triangle. Not a greatly drawn one, but I think you get the idea. So what would this point have to be? Well, you go over so far and directly below this, so this would be x2, and this is so high, so it'd be y1. It has to be the same distance up as this one. So I'm trying to find the distance from here to here, but notice this is the same distance up, so the only measurement we need to worry about is left and right. So that would be, and I'm going to use absolute value, so order doesn't matter, that would be x2 minus x1. This, the only thing you need to worry about is up, down, because you're the same distance right and left, so that doesn't change. So that would be y2 minus y1. So we'll call this d for distance. Pythagoras says distance squared equals this squared plus this squared. Now, absolute value, whenever you square it, it has to be positive because absolute value is positive, so we can actually drop that. Don't have to worry about it. Now I'm going to square root both sides, so distance is the square root of the difference of the x's squared plus the difference of the y squared. Now notice it's not plus or minus because distance can't be negative. So if I say we have two ordered pairs, let's do 3, 4, and let's do 5, 8. And I said find the distance between those 2 points. You would say, okay, distance is the square root of the difference of the x's, so it'd be 5 minus 3, plus the difference of the y's. So it'd be the square root of 5 minus 3 is 2, squared is 4, 8 minus 4 is 4, squared is 16, 4 and 16 is 20, so it'd be 2 square root of 5. Woohoo! So let's say if we had 2, -1, 6, -4. What's the distance between it? So you'd say, okay, it's the square root of the difference of the x's squared plus the difference of the y squared. So -1 minus the -4. So 6 minus 2 is 4, squared is 16. -1 minus the -4 would be -1 plus 4 is 3, squared is 9. And the square root of 25 is 5. So you really just plug it into a formula. Try one for me, my peeps. Do 6, 1, do 11, 3. Find the distance between those two for me, please. So that would be the square root of 11 minus 6 squared plus 3 minus 1 squared. So 11 minus 6 is 5, squared is 25. 3 minus 1 is 2, squared is 4. So it's the square root of 29. And you can't do anything to square root of 29, so we're done. Now there's a couple tricky problems we can do with midpoint and distance. But here, do these problems for me, please. Thank you very much.